Hello, Math 109. We are going to be looking at section 1.2 now. I'm going to just go through several of the first homework problems with you. This will be really helpful to you because it's the same problems you're going to be doing on 1.2. So the first several problems are just going through a lot of just concepts, vocabulary, stuff like that. So I thought it would just be helpful just to go through stuff like that with you. So let's look at number one. Multiplying both sides of an equation by any number results in an equivalent equation. Let's take a look at that. Let's say we have 2 equals 2. I hope everyone would say that that is a true statement. If that's not true, then we are in trouble. So does everybody agree? 2 equals 2? Yes. Well, if we multiply both sides of the equation by, let's say, 3, then what do we get? We get 6 equals 6. So that is true also. So it's an equivalent expression. Let's say we wanted to add 4 to both sides. What do we get? 10 equals 10. Still an equivalent expression. It's an equivalent equation. And divide both sides by 5. What do we get? Back to 2 equals 2 again. So as long as we are multiplying or adding or dividing or subtracting by the same number on both sides, we're going to end up with an equivalent equation. We can also do other things. We can take the square root of both sides. We can raise both sides to a power. And among other things, as long as we do the same thing to both sides of the equation, we're going to end up with an equivalent equation. Let's look back at this problem. It says, multiplying both sides of an equation by any number results in an equivalent equation. It would seem to me when I first read the question, I thought that sounds like it's a true statement, but because it says any number, we're going to say false because it has to be the same number. Multiplying both sides of an equation by the same number results in an equivalent equation. So we're going to say false to that because it can't be any number. Let's look back here. If we have 2 equals 2 and then we decide to multiply this side by 3 and this side by 5, obviously we end up with 6 equals 10, which is not true. So that's why we're going to put false on this first question. Next question. An equation that is satisfied for every value of the variable for which both sides are defined is called a what? All right. So let's say we had 3x equals 3x. 3x equals 3x. Let's plug 1 in. We're going to get 3 equals 3. Let's plug 5 in. We're going to get 15 equals 15. Let's plug 100 in. We're going to get 300 equals 300. We're going to get the same thing on both sides no matter what we plug in for x. And the reason is because the left side of the equation is identical to the right side of the equation. They form what's called an identity. They are the same identity. So it's called an identity equation. Let me give you maybe something a little more. Let's say we had 3x plus 1 equals let's say 5x minus 2x plus 7 minus 6. Now this may not be quite as obvious that this is an identity. But let's just pick a number. Let's plug in 5. If we plug in 5, that'll give me 3 times 5 plus 1 equals 5 times 5 minus 2 times 5 plus 7 minus 6. So that is 15 plus 1, which is 16, equals 25 minus 10 plus 7 minus 6. 15 plus 7 is 22. 22 minus 6 is 16. So these are also an identity. And the reason is because if we just combine like terms to simplify this side, what do we get? 3x plus 1 equals 5x minus 2x is 3x. 7 minus 6 is 1. 3x plus 1 equals 3x plus 1. Now it's much more obvious that this is an identity. Their identity is the same, even though this one maybe was disguised for a minute. Maybe this one was Clark Kent and yet to go into the phone booth to be transformed into Superman, which was always Superman on the left side. Sorry for the bad analogy. Okay. So this is called an identity. And we're going to final check that. go on to the next one. An equation of the form ax plus b equals 0 is called a what? All right, you might have seen this before as mx plus b. Maybe y equals mx plus b. What is that the equation of? Anything that's like a number times x plus or minus any other number. That's a line. It's a linear equation. X is to the first power. It's going to follow a linear pattern. So we're going to say a linear equation. Or the next question asks you, what degree is it? The degree is the highest exponent on the x, or on the variable. So what is the exponent on x here? It is understood to be an invisible 1. So this is a 1 degree or first degree equation. Go to the next one. Determine whether the following statement is true or false. The solution of the equation 3x minus 8 equals 0 is 3/8. Let's solve that equation by hand. 3x minus 8 equals 0. 3x minus 8 equals 0. So we're going to, to solve for a variable means to get that variable by itself, which means we have to get these other numbers that are on the same side of the equation with that x. We got to get them out of there. We got to move them away from the x, so that x will be by itself, and then we'll know what x is equal to. To get rid of these numbers, you have to do the opposite of what they're doing. So to get rid of a minus 8, we're going to add 8. So I'm going to add 8 to both sides. So when I do that, it's gone from the left side, but I have 3x equals 8 now. To get rid of the 3, what is the 3 doing? The 3 is multiplying with the x, so to get rid of it, I will divide it, because that is the opposite of multiplying. So now x equals 8/3. I want to pause here and tell you something maybe you haven't heard before about the order of these steps. How do we know we should get rid of the 8 first or the 3 first? You've heard of the order of operations. Please excuse my dear Aunt Sally, or PEMDAS. Parentheses. That means we should do anything first that is in parentheses or grouped by an operator. Then any exponents, we should do that next. Then multiplication and division, we should do those together from left to right. It doesn't matter if you do division before multiplication as long as you go in order from left to right. And then do addition and subtraction the same way in order from left to right. But this is when we're doing arithmetic. Arithmetic. All right. Arithmetic means like I just have a bunch of numbers and operators and I'm trying to get the result of those numbers and operators. But when we're doing algebra, we already have the result. We're trying to go backwards to get one of the numbers that would have been in the arithmetic to end up with the result. And that's called algebra. Algebra is when you already know the result. You're just trying to figure out what is missing in the operations to form that result. So when we're doing algebra, we're not doing PEMDAS. We're going backwards. We're going backwards through this. So instead of doing PEMDAS, we will do SADMEP. SADMEP. Oop, I misspelled that. SADMEP. SADMEP. Okay. So we do addition and we get rid of addition and subtraction first. We get rid of multiplication and division next. We get rid of exponents after that, and then parentheses after that. So that's why we get rid of the 8, because it's subtracted. We get rid of that before we get rid of the 3, which is multiplied, because we're doing SADMEP as the order of operations in algebra. Okay, so 8/3 should be my answer. Let's go back to the problem. Notice it says 3/8. My answer will be false here. Next question. Some equations have no solution. That is true. Let me show you one. Let's say you had 3x plus 2 equals 3x minus 5. Well, let's try to solve this. Let's get rid of the 2 on both sides. So subtract 2 and we get 3x equals 3x minus 7. Now let's move this 3x over here to get my like terms together. Let me move this 3x over here with this 3x. But what happens? It cancels out on both sides. 3x minus 3x is 0. I get 0 equals -7. Is that true? That is not true. That means there is no solution. There is no value we could plug in for x here to get an equivalent equation. No value of x will do that. It's impossible. Which means there is no solution to this equation. If you look at a graph, 3x plus 2 is going to be a line like that. 3x minus 5 is going to be a line like that. So both of them have a slope of 3. This one will cross at +2. This one will cross at -5. But they're never going to cross each other. And they're always going to run parallel. And they will never have any point in common. They will never share a point. There's no value of x where these two lines will be the same point. So it is possible for equations to have no solution. So some equations have no solution. That is true. State whether the following sentence is true or false. When solving equations using a graphing utility, the solutions are always exact. That would be false. In fact, a lot of times when you're solving equations with a graphing utility, let's say you have these two lines crossing, and they cross at some strange place. Oh, you can't even see what I'm drawing here. Here's what I drew. Okay, and they cross at this point, and let's say that is some irrational number, like 1.3257, blah blah blah, and 2.6534, blah blah blah. Well, the calculator, if these decimals, if this is irrational, it means that these numbers go on forever without ever stopping. So there's no way the calculator can give you an exact answer because it has a limited number of spaces that it can put the answer. So it's going to have to round at some point. Even if it rounds to 10 decimal places, that's still not exact. It's a rounded answer. So maybe we would round our answer here to, like, if we rounded to the second decimal place, we'd say 1.33 and 2.65. And that would be okay. It would be a rounded, approximated decimal. So our answer here, when solving equations using a graphing utility, the solutions are always exact. That is false. They are not. Don't you just love getting that green check mark? I mean, when you're doing Math Excel, you just learn to love the green check mark. Solve the equation 5x equals 45. That's simple enough, isn't it? 5x equals 45. We want to get rid of the 5. The 5 is multiplied, so we will divide it. So x equals 9. Notice that on your Math Excel, you're going to have, on questions like this, a very similar problem, but it will have different numbers, and all of you will probably have a little different numbers. That's a good thing, because you can see how to do the problem, but then you have to actually do it yourself to get the answer for your problem, and that is a good thing. So make sure you don't just put in 9 for that answer. Your problem will be a little different answer than mine because it'll have different numbers. Finally, we get to a problem here that we have to learn something new here. Use a graphing utility to approximate the real solutions of the given equation rounded to 2 decimal places. It says all solutions lie between -10 and 10. We are going to use the graphing calculator to solve equations, and that's going to be great because we don't have to solve these things by hand. The calculator will be our friend here. In fact, if we had to solve it by hand, I don't know that we could. It's not factorable. So this would be very difficult to figure out how to solve by hand. But the graphing calculator can help us out a lot here. So step 1, hit the home button. Step 2. Go to y equals, and we're going to graph this. So let me go back. X cubed minus 7x plus 4. That's what I'm going to put into y1. And since the right side of the equation is just 0, That's all I have to put in. I can just find where it hits 0. In other words, where it hits the x-axis when it has a y value of 0. I forget what it was again. X cubed minus 7x plus 4. X cubed minus 7x plus 4. Let me see if I can zoom in. Let's see. All right, and I'm going to hit zoom standard. Zoom with the op 6 is Z standard. That gets me to my normal zoom window, which is -10 to 10 on the X and the Y axis. And notice the solutions where this thing equals 0 is where this Y value here is 0. So I'm trying to find the X value when this Y value is 0. I'm trying to find these places where it hits the X-axis. So I hit second, calculate. It's the button. It's the option that's the blue option above trace. So second trace or second calculate. And I'm gonna do option 2, which is 0. I'm trying to find the zeros, the roots, the x-intercepts. All those words are synonymous. I'm finding those, and so you can do option 2. Now, the calculator needs you to communicate well with it. It asks you some questions. It says left bound. And the calculator's saying, look, this thing can have x-intercepts all over the place. It could have a lot of them. I need to know which one you want me to find. So you have to, it's saying, how far to the left do you want me to look? So I'm going to click to the left. And let's say I want to find this one first. So if I want to find that one, then I'm going to take this little blinky thing, this cursor, and go to until I know I'm to the left of that point. So anywhere to the left, anywhere in here or here, anywhere to the left is good for the bound. I'm going to hit enter. So then it says, how far to the right do you want me to look? Right bound. So I'm going to click to the right until I know I'm to the right of that point. Anywhere in there is good. Enter. Then it says guess. It really doesn't matter about the guess on this part, but it wants you to put the cursor near the x-intercept. And when you put it near it, hit enter, and it'll tell you the exact, except rounded, answer. Notice a couple of things. This is weird. It says y equals -1e to the -12th. That means -1 times 10 to the -12. That means it is a decimal point and then 11 zeros until you finally get a 1. There's my 1. Which means really it's 0. It's just that the calculator a lot of times can't make itself say 0. It has to round it for some reason. Because this is not an exact answer. That's probably why. Alright, so my answer for x here is what? -2.895. Let me write that down. -2.895. Blah, blah, blah. Now, what does it want me to round to? Didn't it say 2 decimal places? Yeah, notice below the answer box here, it tells you what it wants. Make sure to pay attention to this. Round to 2 decimal places as needed. Use a comma to separate answers as needed. Yeah, I'm going to have to use a comma because I know I have 3 different answers. My first answer will be, if I round this, -2.895, if I round it to 2 decimal places, that means I got to round it to that decimal place. Well, the 5 makes that go up to a 10, doesn't it? So that's going to be -2.90. So that's going to be my first answer here. -2.90, comma. Now let me find the next one. Okay, so now I have to do the same process over again. Second calc, 0, and it says left bound. Well, now I'm looking for the next one. I'm looking for this one. So it says left bound. I'm going to scroll to the right until I get over here in this neighborhood. I just need to be somewhere to the left of this point I'm trying to find. So anywhere in this vicinity here will be fine. I'm going to hit enter here. then it says right bound. I'm going to go to the right until I know I'm to the right of that point I'm trying to find. So anywhere in this vicinity will be fine. I'm going to hit enter. It says guess. I'm going to take it near it and hit enter. And it tells me my next answer. My next answer is 0.602. So if I round it to 2 decimal places, the 2 does not round the 0 up, so it's just 0.60. All right, 0.60. I'm going to go ahead and find my other one before I click over to the other page. So let me do it one more time. Second calc, 0. So I'm trying to find this one now. So I click to the left a little bit. So I'm to the left of it, enter, right bound. I'm going to go to the right of it, enter. Guess I'm going to just go a little bit closer to it, hit enter. And it tells me 2.292, so that's going to be 2.29. Rounded to the nearest second decimal place. So let me put that in. So negative 2.9. 0.60, comma 2.29. Notice I have to put commas between them because it told me to separate those answers. It said use a comma to separate my answers, so I had to put a comma between them. If I didn't, it's going to mark it wrong. And we got the coveted green check mark. All right, here's another one where we're going to use the graphing calculator. All right, we'll learn more about how to solve some of these more complicated polynomial equations by hand later on in the quarter. But let's do it with the graphing calculator. And you can always do this in the graphing calculator, which is nice. It can be your friend. So let me write down this problem. Negative 2x to the fourth plus 9 equals 3x minus 1. And now I can go to this window. All right, what I'm going to do is I'm going to put the left side into y1. And I'm going to put the right side into y2. So that's one way we could do it. Another way we could do it is we could move everything to the same side. We could move the 3x and the minus 1 over here, and it would be negative 2x to the fourth. You can't see that. Plus 9 minus 3x plus 1 equals 0. And we could just take all of this and put it into y1 and find the zeros just like we did on the previous problem. But this may be a little quicker. You just want to put one side of the equation into y1, put the other side of the equation into y2, and that's another way to do it. On the previous problem, the other side was just 0, so we didn't have to do anything like that. So let's do that. Negative. One thing to make a lot of students mess up on these calculators. This is the minus sign, whereas this is the negative sign, the negative button. If you need to put in a negative number, don't use the minus. Use the negative. If you're hitting subtract, then use the minus. So a lot of students mess up on that. Negative 2x to the fourth plus 9. That was y1. And now for y2, 3x minus 1. Okay, so I used the negative button for that negative right there, but I used the minus button right there. And I'm going to hit graph. It went a little slow, but there it is. The way to find the solutions to this equation is to see where these two graphs cross, where these two equations cross each other. The x values of this equation will give us the solutions for x in this equation. The y values will that will give us the result we would get on both sides if we were to plug that x coordinate in for x. So the y values are useful, but they are not going to be necessary to answer this question if we're just trying to solve for x. So this time I hit second calc. And which option do you think we're going to be choosing? We're going to choose option 5, intersect. We're trying to find the intersection of these two graphs. So it says, the calculator, again, it has to talk to you for a little while. It says, well, if there are like 10 different, you could have graphed like 10 different things on here. Which things do you want me to find the intersection of? So it says, what's the first curve you want me to consider here? So notice we have a blue curve right here and we have a red line. So we only have two. It doesn't matter which one you call the first curve. I'm just going to hit enter on that blue curve. Then it automatically jumps down to the red one. It says, what about the second curve? Do you want this to be the second curve? Yes, we do. So we just hit enter again. Then it says guess. This time on the guess, notice it has two intersections. One here and one here. So when whatever you do for the guess, whichever one you're closer to, it's going to give you that one as the answer that it gives you. So that intersection point is negative 1.65. Negative 1.65 is one of my answers. And then let's do it again. Second calc. Option 5. First curve enter, second curve enter. Now when it says guess, I'm just going to take it up here closer to this one and hit enter, and it tells me that the intersection is 1.3. Notice it's 1.318, so I got to put 1.32 if it wants it to 2 decimal places rounded correctly. So let's enter that. 2 decimal places, comma between the answers. So negative 1.65, comma, ooh, I typed it wrong. Negative 1.65, comma, 1.32. Good. Okay. Again, you will need to graph this. Just put all this, since there's nothing on the right side, just put all this into Y1 and find the zeros. Don't do intersection, do zeros. I'm going to skip that problem. On this one, we could solve this by hand, but or you can solve it in a calculator. Either way is fine. Either way is fine. But if I'm going to solve it in the calculator, I'm going to put the left side into Y1 and the right side into Y2, and I'm going to do the intersect option. Okay, again, you can use the calculator. You can do this by hand, distribute, combine like terms, and get x by itself, no problem. Or you can do the calculator. If you do the calculator, type the whole left side into Y1, the whole right side into Y2, find the intersection. Okay, this one is a rational equation, so it's going to be a little bit more difficult to solve by hand, but we can still do it. What we would probably want to do is multiply both sides of this equation by 12. That way, that will get rid of the 3 and the 4. When I multiply both of these terms by 12, the 3 would reduce with the 12. The 3 would become a 1, the 12 would become a 4. The 4 would become a 1, the 12 would become a 3. So now the denominators would be gone, but we don't have to do all that if we do it in the calculator. Just type this into the calculator. Let me show you how to type that in with a fraction. Let me see if I can pull up the Smart View. That might be better for you to see. Here's my Smart View software. It's like a TI-84 emulator on my computer screen. If you want to download this for your computer, you can. Just Google TI-84 Smart View, and it should take you to that. Be able to download that. let's see here. I am going to type, I'm going to go to y equals, and on the left side I'm going to type in, here's how you can get a fraction bar. You see above these buttons, there's an F1, F2, F3. Well, and they're in green, so I'm going to hit alpha because that's my green button, and then hit this y equals, that's going to do F1. And it's going to pull up some options. These are like fraction options. So I'm going to do option 1. That's going to give me a fraction bar with a numerator and denominator. And that's nice. It makes it easy to type in. If you have an older calculator, it may not be that user friendly. I'll show you a different way to type it in if that's your case. So I'm going to put x plus 5 on top of that fraction. Then I'm going to hit to the right. And on the bottom of the fraction, I'm going to put 3. Plus another fraction bar, alpha F1. X plus 1. Over 4. And in y2, I'm going to click down, and in y2, I'm just going to put the right side of the equation, which in this case is just 1. Now let me show you how you could type that in if you did not have a newer model for a calculator. I would use parentheses to do the x plus 5. I would say parentheses, x plus 5, close parentheses. Then the fraction bar, I'm going to use the divide by button because that's the same thing as a fraction bar, divided by 3. Plus, and then more parentheses, x plus 1. So the reason I have to use parentheses here is so that the calculator knows this whole x plus 5 is on top of this fraction. The whole x plus 5 is being divided by 3. Again, the whole x plus 1 here is in parentheses because it's the whole x plus 1 on top of the fraction being divided by 4. So that's an alternative way to type in what I've typed in here at the top. I'm going to go ahead and clear that because I don't need it. I'm going to hit graph. And I'm just trying to find where those things intersect. So second calc. Option 5 for intersect. First curve. It doesn't matter what I call the first curve. The blue one is fine. The red one can be the second one. Enter. Then it says guess. I'm just going to take it over here close and hit enter. And it tells me that the intersection is negative 1.57. Alright, let me see. I'm a little worried about what it says right here. It says simplify your answer, which makes me worried that it may not want a decimal. It may want something else. And if that's the case, I will need to show you a different thing. But let me try typing it in. Yeah. Let's see. I think it wants me. So it wants a fraction. So let's see. Instead of a decimal here, let me make sure I type this in right. X plus 5 over 3, x plus 1 over 4. Okay, so because it wants not a rounded off answer, I'm going to show you a pretty simple way to do that. I'm going to hit second calc, and I'm finding that intersection. I'm just going to do that very fast. Enter, enter, enter. Notice the intersection is negative 1.571429, which is a strange decimal, but I think that we're going to be able to make this into a fraction, and here is the best way to do it. Just get out of here, and the way to get out of there back to your normal calculation window is to hit second quit. Here's quit above the mode button. Hit second quit. And if you do X, hit X. For X, it's going to take the last value that it calculated for X, which was that negative 1.57 blah blah blah. So X, I'm going to convert X, the answer that is stored right now in X, I'm going to convert it to a fraction. The way to do that is I hit math, And the very first option changes something to a fraction. The second option changes something to a decimal. But we want to change it to a fraction, so option 1. So notice, x is going to be changed to a fraction. Hit enter, and it tells me that the fraction is negative 11/7. That's nice. So let me go over here, and instead of typing in this rounded off decimal, I'm going to type negative 11. I'm going to hit the divide by button, and then 7. Okay. Once again, we are just typing the left side into y1, the right side into y2. Notice it says simplify your answer. So don't type decimals. Find the intersection. Moving on. Same old, same old. y1, y2. Simplify your answer. That means don't put decimals. Still the same kind of situation. If it's the same kind of problem, I'm skipping it because we've already gone over how to do it. Okay, this time it says if a comma 8 is a point on the graph of y equals 2x plus 5, then what is a? Okay, this is easier than it sounds. It has a right here as the which coordinate, as the x coordinate, because it's the first thing in the ordered pair. And the 8 is the second thing, so it's the y coordinate. So just put a in the place of x, put 8 in the place of y, and solve it. I'll show you how to do that. Y equals 2x plus 5, and we have the point a comma 8. Alright, so I'm putting a in for x, I'm putting 8 in for y. And so I've got 8 equals 2a plus 5, and I'm just solving for a. So I just subtract 5 from both sides. 3 equals 2a, divide by 2, and a equals 3/2. You can get a fraction bar here by clicking that button, or you can just use the I don't know if it's called a forward slash or a backslash on your keyboard. For me, that is right. That is the button right beside the shift. It's the same button as the question mark. So what was it? 3/2. 3 fraction bar 2. Solve the given formula for the specified variable. So we're solving this equation that has multiple variables in it for h, which means we're getting h by itself. And these other variables are just going to stay variables. So let me write that down, and we'll do that together here. 1 over r plus 1 over q equals 1 over h. All right, I'm going to show you a couple of different answers we could have here. But the way that I'm trying to get h by itself, so I think I'll first try to get h off the bottom, which means to get h off the bottom, I'm going to multiply by h on both sides. That cancels that out. So now I've got h times 1 over r plus 1 over q equals 1. I'm seeing that my screen is kind of freezing there. Okay. So now I'm trying to get h by itself, so I'm going to divide by this whole expression, because that whole expression is being multiplied by 8. So if I divide by that whole thing, 1 over r plus 1 over q, 1 over r plus 1 over q. So I'm dividing both sides by that whole expression. That's going to cancel out here. I'm going to have h by itself. So h equals 1 over r plus 1 over q. And that is one of my, that's a good answer. I'm going to show you how you could get this as a different answer as well, but this should work as one of the answers. But if I wanted to, I could make this look different. I could maybe get it to an even simpler answer, but you don't have to, but you can just follow along. if I want to combine these two fractions into a single fraction, maybe I can make things simpler. Get a common denominator, which will be r times q. So I multiply this by q on the top and bottom, and this by r on the top and bottom. That gives me q over qr plus r over qr, which gives me 1 over q plus r over qr. And then you can keep, change, flip, or multiply by the reciprocal when you're dividing fractions like this. So this can equal 1 times, so keep the 1, change it to multiplication, flip the bottom fraction, qr over q plus r, which is just qr over q plus r. So here is an alternative answer that may be a little bit simpler than the first answer I've got. But I think MathXL will accept both of them. I'm going to try and make sure. But here are my two possible answers that I could type in. And both of these should be correct. Let me type this in MathXL. So I've got, let me use my fraction bar here, 1 over, and then I've got 1 over r plus 1 over q. And I think it's going to accept that. It did not accept that, which means it wants me to keep going to that other answer that was a little bit more involved. So, because it says simplify your answer, and I guess it's saying this is not the simplified answer. So let me go back to all that and put in the other answer that I got after I simplified the whole thing. So fraction bar, qr on top and q plus r on bottom. So if you need to know how to get to this answer, you're going to need to go back to how I just solved it here. So again, what I did was I combined the 1 plus r and the 1 plus q on the bottom by getting a common denominator. I made them into one fraction here. And then it's 1 over that, so I just did keep, change, flip, 1 times the reciprocal of this. And 1 times anything is that thing. So that's how I got to that. Almost done. Oh, I forgot to hit enter. And we got the green check mark. Yay. All right, last one. A word problem. I love word problems. Students tend to hate word problems, but it's like word problems are the only reason math is even useful. Like this is stuff that is actually encountered in the world somewhere. So here it says a total of $83,000 is to be invested. Some in bonds and some in certificates called CDs. All right. And it says if the amount invested in bonds is to exceed that in CDs by $9,000, how much will be invested in each type of investment? Okay. So let me write down that information. Pause it so you won't have to. Okay, so I just wrote down the pertinent information here. The total is $83,000. The bonds is supposed to exceed the CDs by $9,000. And the question is, how much should we invest in each investment? Now, what I like to do is first define my variables according to the final question that it's asking. It is asking how much in each investment. What does it mean, each investment? What are the investments that we're talking about? We're talking about bonds. We're talking about CDs. So how much should go into each of these? So I'm going to let the bonds, I'm going to let my variables be that. I'm going to let X be the bonds, or the amount of money in the bonds. And I'm going to let Y be the amount of money in the CDs. All right. So now I'm going to make an equation with an X and a Y in it based on the information given to me. Okay, what is the simplest equation I can get from the information given? The total is 83,000, which means together they have to make 83,000. That's a simple equation. X plus Y equals 83,000. The second equation is going to be from this information. The bonds, X, should exceed the CDs, Y, by 9,000. So X is supposed to be 9,000 more than the CD, than Y. So X equals Y plus 9,000. That means X is Y, but 9,000 more than Y. All right, let me pause it just for a second. Okay, from this point, you have to solve now this system of equations. And the reason I had to make two equations is because I have two variables. If you have two variables, two unknowns, you can't solve that with just one equation. You have to have two equations to solve for the two unknowns. There are a lot of ways we can go about this. Elimination, substitution, or the calculator. I'm going to do substitution because that seems to me to be the easiest, quickest way to do this, I think. What I can do, since X is by itself here, all I've got to do is take the Y plus 9,000 and substitute that in for X right here, because it's equivalent to X, right? I'm just substituting it in for something that it's equal to. That's why it's okay to do this. And so I'm going to say Y plus 9,000 plus Y equals 83,000. So now I don't have two variables in this equation now. I just have one. Sorry for my bad handwriting. I just have Y, and I can combine them. The Y and the Y can go ahead and combine and make what? 2Y plus 9,000 equals 83,000. Now just solve for Y. Move the 9,000 over, divide by 2. What's that going to be? That's going to be 74,000. Then divide by 2. And Y equals 74. This was a 74 about to. That's 37,000. So here's Y. I've got my answer for Y. I know how much was in CDs. How can I get my answer for X now? Just take the 37 that you found for Y and substitute it back in for the Y in either one of these equations, and you will have X. So X equals 37,000 plus 9,000. X equals, what is that? 46,000. So let me go back to the problem. The amount invested in CDs, that was Y. CDs was Y, so that's 37,000. And the amount invested in bonds, that was my X variable. That was 46,000. And that is good. All right, so we're done with section 1.2 homework. Hope you do well on it, and I'll see you next time for section 1.3. Oh, I need to tell you this. I'm going to make this be due either Wednesday night if you're in the Monday, Wednesday class, or Thursday night if you're in the Tuesday, Thursday class. This is going to be in addition to, I'm going to go ahead and assign 1.3 as well. So look for the 1.3 video coming up soon.